Okay, in this tutorial question, what we're going to do is look at complex numbers. So essentially what we have here is two complex numbers. Z1 equals 7 plus I and Z2 equals 1 minus 2I. Okay. Now essentially what we do here is we have a real part first, which is 7 and 1, and an imaginary part, which is I and minus 2I respectively. Okay. So what we're asked to do is write the following expressions to form A plus IB. A here is the real part, B is essentially stands for the imaginary part. So the two expressions are Z1 over Z2 and then 1 over Z1. Okay, so we'll just do them one by one. Okay, and this is the first one here. This is part A. Okay, Z1 over 7 plus I over 1 minus 2I. Okay, now let's just be sure about some terminology. The bit above the fraction is called the numerator, the bit below the fraction is called the denominator. And what we're looking for is complex conjugate of the denominator. Now essentially what we have to do here is we have it in standard form, real minus imaginary, or plus or minus imaginary. So what we have to do here is change, to get the complex conjugate, what we do is change the sign there. And what we do with that complex conjugate, essentially we multiply above and below. Let's just move that page there so we're not looking at too much going on. Multiply the numerator by the complex conjugate and the denominator by the complex conjugate. This is essentially multiplying by 1, but because both of these are the same, this is constructively multiplying the whole thing by 1. So we don't change the expression, we just simplify it. That's the beauty of this. Okay, and when you multiply a number by its complex conjugate, you should get a real number. Okay, so here is my calculation. So what I'm going to do here is I am going to break it up into numerator and then denominator. Okay, so 7 plus I times 1 plus 2I. So let's just multiply by the numerator by 2I. 7 times 2I gives us 14I. I times 2I gives us 2I squared. We'll come back to that shortly, but we'll just leave it as 2I squared for the time being. Now, 1 times 7 plus 1 is 7 plus 1. Now, you just notice the way I sort of kept it I sort of split it out there. So we have the real, the imaginary parts, and the imaginary squared parts. Just sort of separate them out. 14i plus I is 15i, and 2I squared is 2I squared. What we can do there actually is we can state that as 5 plus 15i. Okay, so what happens there is 7, let's just call 2I squared is, I squared is minus 1, so 2 times minus 1 is minus 2. 7 plus minus 2 gives us 5. So essentially the numerator is 5 plus 15i. Now, the denominator works more or less the same. I've done it in very long form in this instance, okay? But essentially, it's more or less done the same way there. So I'll just let you read through it yourself if you want. Essentially, what we do is we end up with 5, okay? So ultimately, our answer is, let's just sort of move that down a second. Let's move the page up there. Whoa, there we go. So essentially the answer is 5 plus 15i over 5, which is 1 plus 3i. That is the answer to the first part, Z1 over Z2. I'm just going to pause it there and set up for the second part. So the next part is, this part B is 1 over Z1 equals, express that out. Get an expression in terms of A plus IB, where we're trying to express 1 over Z1 in that form. So what we have here is 1 over 7 plus I, okay? And essentially what we're doing is carrying out a complex number division here, more or less the same way. We multiply the denominator by the complex conjugate of the denominator, and the numerator by the complex conjugate of the denominator. Essentially what we're doing here is we are treating 1 as a complex number, 1 plus 0y, just doing it more or less the same way. So I'll go through this one very quickly. The numerator works out to be 1 times 7 minus I, and the denominator is difference of squares, 49 minus I squared. Okay, just going out a shot there actually. So we piece that all together. 49 minus I squared is 49 minus 1, which is 49 plus 1, which gives us 50. So essentially what we do here is we end up with 7 over 50 minus 1 over 50 times I. So that is the answer to the second part. Now there's one final part here to do here. Okay, what we're asked to do here is investigate if the conjugate of Z1 over Z2, which is something we've calculated already, is equal to the conjugate of Z1 divided by the conjugate of Z2. It's a little bit hard to read here from this, just take my word from it. Conjugate of Z1 divided by conjugate of Z2. Now the left hand side here is essentially what we've done already. So the answer to part A previously was 1 plus 3i, so the complex conjugate of that is 1 minus 3i. Okay, so that's just reverting back to part A, which we've done at the start of this video. The the right hand side, the complex conjugate of Z1 divided by the complex conjugate of Z2. Now, more or less what we've done here, what we're about to do here is what we've done already. It's a complex number division, okay? 7 minus I divided by 1 plus 2i, okay? So the complex conjugate of the denominator is 1 plus 2i, and we've worked that out already, that is 5. Actually, that should be a minus there. Sorry, I apologize. That's supposed to be a minus. Okay. Now, 1 plus 2i times 1 minus 2i gives us 5. This is something we've actually done already. So, in part B. So, and part A, actually. So, sorry, in part A. So, what we have to do here is just multiply the numerator by 7 minus I times 1 minus 2i. If we work that out, you should find it is 5 minus 15i. Okay, 5 minus 15i divided by 5 gives us 1 minus 3i. Okay, so in this instance, the left hand side is equal to the right hand side. Okay, so the proposition is true in this instant. So that's long enough, so I'm going to leave it there. I just have another video now where I'm going to do something slightly unusual.